Okay, folks, welcome back. I just want to put a quick video here together for you. I've been getting some questions on number 8 and number 10 in WebAssign. Strategy here is a little different than some of the other differential equations we've solved. So we know this. We've got a function that behaves like this. It's an exponential growth model. Normally, when we're solving one of these for particular solutions, we're given a point there when t equals 0. But that's not the case here, which is what makes this one a little bit more challenging. We've got a point here at 1, 3 and here at 3, 2. I'm going to go ahead and plug each of these points in and see what we get. So let's first look. We'll call this equation number 1. When I plug in 1, 3, I get y equals 3. That equals c times e to the k times 1, which is just k. Now let's look what happens when I plug in the second initial condition. I get 2 equals c times e to the 3k. Okay, now let's actually take these two and divide one out by the other. So let's take equation 1 and divide it by equation 2. That gives us 3/2 equals, well, the two c's cancel, and then I have e to the k divided by e to the 3k. That's e to the negative 2k. Okay, so that's great. Now, I don't like negative exponents. They frighten me, so I'm going to rewrite that as 2/3 equals e to the 2k. And you're going to have to think about that for a little while as to how and why I was able to do that. But at this point, I think I could take the natural log of both sides. And through a little bit of magic, I get this, which tells me that k is actually equal to the natural log of 2/3 divided by 2. That's not the end, though. We now have to go back and solve for c, and I can do that by going back to either one of these two equations and substituting in what I know. I have now 3 equals c times e to the ln of 2/3 divided by 2. Oh, well, that's pretty straightforward. All I have to do, this right here, that's a constant. So I can divide both sides by that quantity, and I get c equals 3 divided by e to the ln of 2/3 over 2. Make sure you know that that entire quantity is the exponent on e, and you're done. Good luck. Folks, last thing I'll mention here is the work that I just did. That's actually WebAssign number 8, but you'll need those same strategies on number 10. So number 10, also, you're given 2 points that are not, I still call them initial conditions, but it's not at time t equals 0. But you'll need the same strategy there to come up with the model for number 10. Let me make one last comment here. Let's go ahead and take a look at this constant. I've kind of left that thing in a little bit of an ugly format. I just want to show you that you can rewrite that. So let's take a look at that. I've got 3 divided by, I'm going to write that as e to the 1/2 times ln of 2/3. And then that is equivalent to 3 divided by e to the natural log of the square root of 2/3. The reason why I want to write it that way is because I can then rewrite it as 3 divided by the square root of 2/3, which is equal to 3 times the square root of 3/2. So if you're somebody who's bothered by an e to the ln of something and you want to rewrite that without the e's and the logarithms, you can. Okay, now I'm officially done.